Hey guys, how are you? Welcome back to the channel. Today is day 32 of upskilling myself, and today I solved three DSA problems. So let's move on to the DSA problems that I solved. So the first problem is maximum subarray. So what we have to do is we have to return the sum of the maximum subarray. Okay. So if you see over here, this subarray is giving the maximum sum. So if you see 4 plus 2 is 6 plus 1 is 7, 7 minus 1 is 6. Okay. So 6 is our output and we don't want to include minus 5. So because if you include minus 5 plus 4, it would be 5. Right. So we can either do it using prefix sum and all, but the most optimal way of doing it using the cadence algo. So it's a greedy or a DP algorithm. So if you see, we define two variables. One is a maxsum and one is a sum. So the maxsum is defined to int min, and the sum is defined as zero. Sum will change after every iteration, and maxsum will change only if we get a sum greater than the maxsum. Okay. So we'll traverse the array, and after that, sum is equals to sum plus num. We'll add every number into the sum, and then if the sum is greater than the maxsum, we will update the maxsum, and if the sum is less than 0, which means it's negative, the number is negative, which makes the sum as less than 0, then we'll set the sum as 0, because there is no use of making the negative sum as positive and then finding the maximum sum. Okay. Then after that, if the max sum is still int min, which means that we haven't found any maximum, which means that the array is empty, then we return 0, else we return the maximum. Okay. The next problem is best sizing pair. So what we have to do over here is, if you see 8, 1 and 5. Okay, so 8 is the first element in the subarray and 5 is the last element in the subarray. So 8 plus 5 is 13, and we have to minus the distance. So the distance is 2, so minus 2 comes out to be 11. Okay, we can do it. And if you see, if you consider 8 to 6, it can be like 8 plus 6 is 14 minus 5. So it's 9. So it's less than 11, right? So we have to find such pair which will give the best sightseeing pair, which is 11. Okay. So what we do is we have to do it in one pass. We can either do it using n square complexity using two nested loops, but we don't want to do it. And it's if you think like it is like the typing rainwater problem which is solved, where we store the previous left max and the previous right max. Okay. So same here, we'll store the previous max, and yeah, we will reduce it by one after every iteration. If it's not larger, then we'll store the current iteration minus 1. Okay. So we have defined two variables. The answer is equals to 0 and current sum is equals to 0. Then we traverse the array, and the answer will be the maximum of answer and the current sum plus number. So it will be like the current sum, which is addition of this plus the current number. In this case, it's 1. Okay. Then the current sum will be the maximum of current sum minus 1. As we are moving ahead in the iteration, we have to reduce minus 1 for the distance, and the max of num minus 1. So if you see num is in this case 5, so 5 minus 1 will be 4. It should be added because we have to also consider the distance. Then we return the answer. The third and final problem was maximum product subarray. So we have been given an integer array in nums, and we have to find a subarray that has the largest product, and we have to return the product. Okay. So we have to take care that whenever we see a 0 or a negative number, we have to do something, because 0 will make everything 0 and we don't have to consider it, and negative number will just reverse the whole thing. So if any number is the greatest before negative, then it will be the lowest when we do negative. Okay. So we have to do something regarding it. So what we do is we define two variables, current min and the current max. So everything and the result, the final result, which is the product, everything is assigned the first element in the array, and then we traverse the array. If the nums of I is less than 0, which is it's negative, then we have to swap the current min and the current max. Okay. And the current min will be the minimum of nums of I and the current min into the next array, which is the current iteration. Okay. And the current max will be the maximum of nums of I and the current max into nums of I. And then the result is the maximum of result and the current max. Okay. And then we have to return the result. Then for development part, I did some AWS advanced services revision and YouTube stuff, and did the revision of all the DSA problems that I solved till now. Thank you guys for watching, and see you on day 33.